Okay, so good afternoon, everyone. I welcome you back to my YouTube channel, and presenting before you this wonderful tutorial is Hampeyo Kleeman. So today we will be doing irrational numbers, and I'm going to explain the easy way how to prove that a particular given figure is an irrational number. What are irrational numbers? Irrational numbers are simply numbers that cannot be expressed in the form A over B. And from the previous video tutorial that I had made, I think I explained to you that when a figure is expressed in the form A over B, then it signifies rational numbers. And rational numbers are integers. And of course, we said that under the conditions that B should never equal 0. Now, when we look at the examples of irrational numbers, we have the square root of 3, the square root of 2, the square root of 5 plus 3, and the square root of 5 itself plus 1. Even a pi is a very good example of an irrational number. Okay? These are numbers that cannot be expressed in the form A over B. Okay? Pi is an irrational number because we can check from the denominator that actually this 7 can get into 22 and we can have some number. Okay? So sometimes they'll give you a set of numbers, then they'll ask you to come up with prime numbers, even numbers, and also irrational numbers and rational numbers. So you need to know what exactly these are. Okay, we call them radicals. If you see a number with a square root, we call them radicals. So any number of a radical, okay, any radical number or any number that has a radical should be considered as an irrational number, except if it does not have a common factor. All these numbers I have highlighted on the top are irrational numbers. Okay, they are all irrational numbers, and you must be able to appreciate that. How do we prove irrational numbers? To prove irrational numbers, we use what we call the proof. I forgot to put that. The proof by contradiction method. And that makes it very simple. Okay? That makes it very simple. Proof by contradiction method. How does it work? How does it work? I think I have some exercise work which we are going to use together, and I'm going to prove to you how to prove that actually square root of 3 is irrational, square root of 2 is irrational, square root of 3 plus square root of 5 is actually also irrational. And please, you need to get these concepts because they'll bring something like this. They can also bring square root of 5 minus 1. You need to know how to solve this. Let's get started. So look at this. Okay, so I'll pick the second one. Okay, because it's just the same. If you have the root of 2, okay, we know that root of 2 is an irrational number, but we want to prove that actually root of 2 is irrational. So we use what we call proof. What is the concept? The concept is proof by contradiction method. So we are going to contradict that actually square root of 2 is rational. Instead of saying irrational, I will say it is rational. Then I explain to you that rational numbers can be expressed in the form A over B, where A and B are integers or coprimes, and b should never equal 0, because if b equals 0, the equation becomes undefined. So in this case, I will say, I will contradict that actually square root of 2 is rational. If it is rational, then automatically, please follow the steps, it can be expressed in the form a over b, where a and b are integers or coprimes, and b must not equal 0. If that is the case, then I can say that I can put my square root this side and my square root this side, so that these 2 and this square root can cancel, and I'm going to remain with a 2 equal to a power 2 over b power 2. After reaching here, I can cross multiply. If I cross multiply, I'm going to get 2b power 2 equal to a power 2. Now, when you express it in the form a over b, you need to make sure that a over b should never have common factors. Okay, this is what we want. Because if common factors exist, then it becomes rational. Okay, we don't want a over b to have common factors. If we do not have common factors in a over b, then we know that what we have is irrational. If we have common factors, okay, in a over b, then what we are dealing with is a rational number. Okay, so now after reaching here, we have something like 2b to the power 2 equal to a to the power 2. Now notice that when we multiply b squared to a factor 2, we are getting a quantity a to the power 2. Okay, but at the same time, if we were to divide this number, okay, all right, so when we multiply 2 by b to the power 2, we are getting a as a single quantity number, right? Because whatever number that we can put on b, if we multiply it by 2, definitely we are going to get a single number, and that number is going to be rational, right? So now here the whole concept is this: if I divide by 2, even here by 2, I will discover that I'm going to have b to the power 2 equal to a power 2 over 2. So now look, concentrate on this particular side. Have you seen what is happening? If you divide a to the power 2 by 2, you are going to get b as a single number. This tells you that a is an even number. Why? Because any number which can be divided by 2 is an even number. Because if we divide a to the power 2 by 2, we're getting b to the power 2 as a single number. So in this case, we are going to say that a squared, since it can be divided by 2, we are going to say that a to the power 2 is going to be even. Okay? And we know that a to the power 2 is the same as a times a. And since we said that a to the power 2 is an even number, we know that even number multiplied by even number is equal to even number. Odd number multiplied by odd number is equal to odd number. Henceforth, a itself is also even. Okay? Henceforth, a itself is even. Okay? Now, if a is even. This tells you that a as a single factor, a as a single factor is equal to 2 multiplied by some quantity k. Okay? Okay. So, if a is equal to an even number, then definitely we know that a is divisible by 2. Okay? Henceforth, we can say that a is equal to 2 multiplied by some other number, which can be, to which the quantity we can use k. Okay? If this is the case, then we are going to get this particular, please just follow the steps. We are going to get a is equal to 2k and put it where there is actually a. So in this case, we are going to get this particular equation. So say 2b power 2 is equal to a power 2. Okay? A power 2. Then we are going to say that 2b is equal to, so 2b to the power 2 is going to equal to, then while there is a, I'm going to put 2k. Okay? I'm going to put 2k. Then after that, this is going to be 2b power 2 is equal to, then this is going to be 4, then k power 2. Then from there, I can divide by 2 like that. I can divide by 2, and after dividing by 2, I'm going to get b power 2 is equal to 4. Sorry, so this and that can cancel. I'm going to get a 2. Okay, so this is going to be a 2. This is going to be 2k power 2. Now look at this. This is very interesting, because after we did all our calculations, at first we had this particular equation here. Okay, and this equation was 2b power 2 was equal to a to the power 2. And we proved that actually a was even, right? A was even. Why? Because we said that if we divide by 2 and by 2 this side, these 2 can get into a to give us b to the power 2 as a factor. Now notice what is happening here. We can also divide by 2 this side and 2 this side, so that when we remain with some k to the power 2, we are going to get b power 2 over 2. If we divide by 2 into b, we are getting k to the power 2. That implies that b is also even. Okay? B to the power 2 is also even. Now look at this. Look at this. Look at this. Our equation was root of 2 was equal to a over b. Then we said that a over b should never have common factors. By common factors, we mean anything to do with maybe 3 over 6, 2 over 4, then let's say 3 over 9, because we know that all these have got common factors. The common factor here is 3. Common factor here is 2. Common factor here is 3. If we get anything with a common factor, we know that it is rational. Okay? But if we get anything without common factors, we know that it is irrational. All right. So in this case, we know that this b is actually even. Okay? And it's an integer. And then on the other side here, we notice that a was also even, right? Henceforth, common factors are there. Okay? Common factors are there. Henceforth, the root of 2 cannot equal to a over b, where a over b has no common factors. Henceforth, proven. That is how you prove this. Just you need to show all these workings that I have highlighted. So this is how you prove that actually square root of 2 is irrational. Okay, let me get the third question. This is very simple. Let's get to do the third one. So the third one, they are saying the root of 3 plus root of 3 plus root of 5. So that was my third question. Okay, so root of 3 plus root of 5. What is the concept? Proof by contradiction. So I'm going to contradict that actually this is equal to a rational number. Okay, so I'm going to say actually root of 3 plus root of 5 is rational, meaning it can be expressed in the form a over b, where a and b are integers. If at all we find that our ratios have got integers, please notice what I'm going to do here. If in trying to prove that square root of 3 plus square root of 5, we get to discover that we have integers at the far end, then definitely the square root of 3 plus the square root of 5 can't be rational, because irrational numbers, they actually do not have integers. They do not have coprimes. And they do not have anything like that. Okay, so please get to understand this particular concept. Root of 3 plus root of 5 is equal to a over b, where a and b are integers or coprimes, and b should never equal 0, because if b is equal to 0, it becomes undefined. So after reaching here, I can say that root of 3 plus root of 5 is going to equal to a over b. Then I can square root everything like that, so I can square everything to power 2, even here power 2. Then this is going to be root of 3 plus root of 5, then root of 3 plus root of 5. Okay, like that. Then this is going to equal to a power 2 over b power 2. Then this is going to be root of 3 multiplied by root of 3. This is going to be 3 plus root of 3 multiplied by root of 5. That is going to be root of square root of 3 multiplied by 5 plus 5 multiplied by root of 5 multiplied by root of 5 is equal to 5 plus root of 5 multiplied by root of 3. That is going to equal to 5 multiplied by root of 5 multiplied by 3, and then that is going to equal to a over b squared, like that, a squared over b to the power 2. Then we are going to say that 3 plus this is going to equal to root of 15 plus this is root of 15 also, then plus 5, then that is going to equal to a power 2 over b power 2, and that is going to be 3 plus this is 2, then root of 15 plus 5 equal to a power 2 over b power 2. So altogether we are going to get something like, what is 3 plus 5? That is 8. So we're going to get 8 plus 2 root of 15 equal to a power 2 over b to the power 2, like that. When we reach here, we can say that root of 2 root of 15 is going to equal to a power 2 over b power 2 minus 8, then over 1. Then we can do our calculations. We know that, we know that this is going to be b to the power 2, then this is b to the power 2 into b to the power 2. Notice that that gives us 1, then we're going to get a power 2, then minus, minus, this is going to be 1 into this is going to give us a b power 2, this is going to be 8 b to the power 2. So at the end, we are going to get 2 square root of 15 equal to that. Then when we reach here, we can say multiplied by 2 over 1. Even here multiplied by, we can say, let me just cancel that. All right. So here we can say 1 multiplied by 2. Even here we can say 1 multiplied by 2. So that we can cancel this. So we're going to have the square root of 15 equal to a power 2 minus 8b power 2, everything over 2b to the power 2, like that. When you reach here, notice that at the far end, what you have here is a radical, okay? Then this is the simplest way to prove it. What you have here are integers, right? Because we know that upon reaching here, we know that a power 2 is even. Then we know that b power 2 is also even. If this is true, then we also know that a itself is even and b itself is also even. But we know that all even numbers are integers. And in the first place, I mentioned that irrational numbers do not produce, they are not integers, okay? But at the far end here, what we are getting is an integer. But what we have on the left hand side is not an integer. This is a radical, okay? It's a radical. But what we have here, all these are integers. Henceforth, this is not the same. What is on the right hand side and what is on the left hand side are not the same, okay? Henceforth, this shows you that root of 3 plus root of 5 cannot equal a over b. That is very simple to solve, okay? So I want you to solve for me question 4 and question 5. Then you can also do the first one. Please ensure that you do the work, you send it to me, then I'll be able to mark you. Thank you so much.